and complicated. They take vast amounts of water, electricity, and land. But what
False.
Data centers are expensive and complicated. They take vast amounts of water, electricity, and land. But what if we didn't have to build data centers on land at all? What if we could build them in space?
Just false.
That's exactly what companies like Blue Origin and SpaceX are attempting to do. In fact, earlier this year, SpaceX filed an application with the FCC asking to launch a cluster.
I cannot debunk it every time that somebody makes a claim. I can't. We've already debunked it. We fully debunked. It's an actual debunked. Next.
Of up to 1 million satellites to build an orbital data center.
What about me? Buddy, it's not because you want things to be... Okay, listen. It's not because you want something to be true and you're going to get me mad if it's not true, that it's true. It's not because you get mad that it becomes true. Buddy, it has been debunked. Flat out. Flat out.
That's part of their pitch to investors ahead of their anticipated IPO later this year. But just...
All right.
Hot when they run, but also Sam Altman says that the average ChatGPT query uses around 0.000085 gallons of water, or roughly 1/15 of a teaspoon. But then at the same time, somehow a Morgan Stanley projection predicted annual water use for cooling and electricity generation by AI data centers could reach around 1,000 billion liters by 2028. That's 1 trillion liters, an 11-fold increase from 2024 estimates. AI water use is extremely easy to mislead people about for a few different reasons. And one of them is that the average American has not updated their understanding of what water use is since they were in elementary school. And this is fine. We don't all need to understand this stuff, but then it gets dragged into the discourse, and of course we all talk out of our asses while experts rub their temples from the sidelines. So look, as far as I can tell, though OpenAI does not let people inspect the sources of their data, both of these numbers are true. 1/15 of a teaspoon per query and 1 trillion liters of water per year by 2028. And you might think, okay, well, Morgan Stanley must just be imagining a future where there's a tremendous number of queries. But no. Actually, no matter how you multiply 1/15 of a teaspoon, you're never going to get anywhere close to 1 trillion liters of water use. The thing is, water consumption analysis, indeed any resource consumption analysis for an industry or a product or a conversation with a chatbot, is really tricky to do. There are multiple fields of economics and science devoted to this. If you're going to try and package that up into some nice, neat numbers that the average person will understand, you're going to be fudging a lot of stuff. So this seems like a good time to actually get into why it's so hard. But first, this video is brought to you by a little outfit called Ground News. Ground News is a website and app that pulls coverage of the same story from tons of different outlets from all over the political spectrum and all over the world. 40% off the Vantage plan using the QR code that's been on the screen the whole time, or by using my link, which is ground.news/Hank, which you can also click in the description. So, why do data centers use water at all? So the actual computer chips that do the processing for AI get hot when they run, but also they don't work as well when they get too hot. So you gotta cool everything down so that everything runs optimally and the chips have their optimal lifespan. And you're optimizing everything so you get like the most processing power per unit of dollars you spend. Part of that is cooling everything down. And one of the most efficient ways to do that is with water. Many facilities use evaporative cooling, where they literally turn clean water into water vapor, and that water vapor carries the heat away. It's warmer, and it's taking the heat away. Good. Now, that's not the only way you do it. Some sites recycle water, or they use non-potable water, so water that's come out of a sewage treatment plant that you couldn't drink. But most of them still rely on fresh municipal water, the same water that a water company would be delivering to you, they are delivering to them. And this is important because municipal water is a kind of water. And yes, there are many different kinds of water, and the differences matter. Because look, no one's destroying the water here. The water that evaporates, it's just gonna fall down somewhere else eventually. But it does evaporate. It does go away. It is used up. And this is generally clean water that could be used for something else. It's been processed to be clean enough to drink and delivered using the same infrastructure as the rest of the city. And all that processing and all that infrastructure costs money, and it can't handle an infinite amount of water going through the system. This is industrial water use, but it's usually the same water as everything else. It's the municipal water. Now, OpenAI did not release information on where the water use figures come from, but I can make some guesses. First, Sam is talking about the water use per query. But importantly, different queries work different ways with AI. And many queries will actually result in multiple queries you never even see. This is something Sam Altman knows, but it's not something that most people know. Behind the scenes, when you ask GPT-5 a question, it frequently thinks. They call this reasoning models, and it thinks by like preparing and sending out other queries, and then reading the results of those queries, and then sending out more queries, and then maybe like it might spur a search of the internet. So if you ask it a somewhat complex question, it will run an initial query, and then it will take that response, it will evaluate it using another query. It sometimes runs follow-ups until it's happy with the final answer. All those extra queries are additional queries. So one query might not be one query. Sometimes it is, but sometimes it's a bunch. So this in itself might multiply this 1/15 of a teaspoon by like 15. I don't know, of course, because OpenAI doesn't share any of this information. But even in that situation, it's still just a teaspoon. I drink teaspoons all day long. That's, for me, not really the lie in Sam's lie here. And I am going to call it a lie because I think it is. The actual lie is that it's only counting the water used during the part of the life cycle when you're actually querying the chatbot, not all of the other parts of the process that are necessary for this system to exist. This is the big difference between Morgan Stanley's analysis and Sam Altman's. There are a lot of other...
We watched this, but Chad doesn't believe it. We have to do it again because every single time that we've watched something that is backed by at least Unless you have better research, or then you have something else that's better. Wait, what
Parts
else?
of this process
I understand.
that are
I mean,
not the
you really-
final step of the consumer querying the chatbot. And you've probably thought of one of them, but you probably haven't thought of the biggest one. And I want to do a test right now and find out if I'm right. So if you thought of one place where the chatbot is using water that isn't the query, you probably thought of the training. The thing about these systems is that the training never really stops, even while we're using one model like GPT-5, which is actually a bunch of models all stuck together. OpenAI and its competitors are constantly training newer, bigger versions that no one can use yet. And to create these models, like the system runs for weeks or months on enormous clusters of GPUs, burning through electricity and water for cooling. It's not really fair to treat that training footprint as separate from every conversation you have with the model. The conversation could not happen without the training. So if you want to be honest, you gotta make some choices. So probably you want to spread the water used to train all of the models in GPT-5 and spread it across every query people make. Problem here is,
Whatever. Yeah, whatever. I mean, I like that chat. You see now. It's not proving me wrong. Bro. Just go watch it. Just go watch it. We're not gonna do this.
How feasible is this really? To find out, we asked an expert.
It's just incorrect. Google how much water it takes to maintain a golf course. Google how much water it takes to irrigate crops. Look how much you need to compare it with actual figures. You can't just say a number. Guys, this takes 5 liters of water. Like you know how that comes into play and what these quantities actually mean for society. You don't know these things. You haven't looked at it. You didn't even watch the video. So we try to call me out for my YouTube video research or whatever, right? You need to come up with a better one. Otherwise, mine just wins. Like, I don't know what you want from me. Like,
I'm a computer architect by training, which is to say that I design processors and memory systems and think a lot about how they get deployed.
And computer architect is the coolest name in the computer science field, I think.
I think so.
Before we launch into space, we need to understand what data centers need on the ground, namely an immense amount of electricity hardwired in through cables connected to the grid. And data centers also generate heat, so they need to be cooled down, either with air or often using vast amounts of water routed through cooling towers.
This warm water, when it hits those cooling towers, some of it will evaporate and bring the temperature back down.
And inside these massive buildings, each server in a rack needs to work in tandem with the ones around it. In order to do that, they need to share data by transferring it through physical cables, often fiber optic.
The power of data center compute is really in the networking equipment. We are able to harness massive amounts of compute across many different servers and coordinate that computation to answer questions that we wouldn't be able to answer on a single computer or on a single machine.
But when you try to translate that computing power into space, things get more complicated. Satellites already in orbit are typically for one of two purposes, either data collection, like looking at weather patterns or taking satellite images, or communication, like SpaceX's Starlink satellites. Both of those cases are less power intensive than doing real-time computations up in space. So the satellites for an orbital data center would need to be designed differently, with even larger arrays of solar panels.
If we were to launch these data centers into space, we would be able to use these solar panels and get access to inexpensive or essentially free energy from the sun.
In order to get predictable sun exposure, these satellites would have to maintain a particular orbit, known as a sun-synchronous orbit.
If you were to put it into sun-synchronous orbit, the satellite would pass over the particular location on the planet at the same time every day. And if you were to pick a particular orbit, where you are following the dawn-dusk line, the point at which daytime turns to nighttime, the satellite might be able to get nearly constant exposure to solar energy.
That's cool.
But cooling is a problem too. There's no air in space, so we can't run cool air over the chips like we can on land. And we can't pipe in extra water to cool down the chips
Isn't
via
it
evaporative
cold
cooling
in
either.
space?
So satellites might have to rely on closed-loop radiator panels, running a fixed amount of water over the chips outside the satellite to cool down via infrared radiation.
That sounds pretty
and back
easy,
again.
actually. This is
But
what
those
computers
radiator
do.
panels can be heavy, requiring more fuel to launch into space.
Figuring out the design of the satellite is going to be increasingly important because that will determine the weight profile and the cost of the launch.
Radiation in space is also a concern for computer engineers. If a high-energy particle strikes a GPU, it can literally flip a 0 to a 1, or vice versa.
my
That could mean the
God.
difference between calculating the correct answer to a problem and getting the wrong one entirely. So for the data center to be
This has been half debunked as well. These days, it's in my understanding that this has been priced into the chips and shit, and they're more resistant to it. Where I could be wrong though.
useful, we'd need solutions to prevent or correct those errors.
I would envision 3 types of strategies.
They
The first
had
type
to
of
because of
strategy
aviation.
would be essentially to detect when those errors have arisen and then correct them. Alternatively, we could compute the same process, the same job, it's the same task multiple times and compare the results. But as you might imagine, this is expensive because instead of having one GPU, you would now have 3. The third option we would have to protect chips and computation from radiation would be just add some sort of physical shielding that encloses the servers and prevents more of those high energy particles from hitting that chip.
But there's another problem. How do we get the data from Earth to the satellites and back again?
When we think about communication from Earth to one of these satellites, we are relying on radio frequency communication. And when we think about the satellites communicating with each other, depending on how precisely these satellites are positioned, they might be able to communicate via lasers. Essentially, one satellite would send a laser signal to another satellite, and they would modulate that laser to communicate data across that signal.
With lasers, data transfer speeds are pretty high. But the problem here is bandwidth.
If you wanted to send quite a bit of data from Earth into space, it might be better to simply put it on a disk and launch that disk into space.
That might mean that implementation is key. Instead of sending massive amounts of data back and forth, send the satellite up, preloaded with a training data set for an AI model.
You would pose your question to the satellite. The questions might be kind of short, right? Because even if you have a massive document or database that you want to ask a question against, your question itself may only be 120 characters.
I have to be honest with you. I feel like this video is finding problems that aren't there and finding a way to somehow find some fear mongering. Like it just is how it feels to me.
Or something like that. So imagining a scenario where you send only a few hundred tokens up into space, that is certainly feasible and possible for.
What do you think people said when people said, yo, let's put internet in space? What do you think people said when Starlink was first introduced as an idea? Probably people said this times 25, times 30 of oh, this can't be done. Buddy, let the ones that actually change the world do what they do. Like, I mean,
for AI inference.
But with increased traffic, bandwidth may still be an issue, meaning it could take longer to get an answer to your query when compared to a data center on land. Ultimately, it comes down to one question. Does the math work out? Large solar arrays, radiator panels, and chip shielding all add cost and weight, meaning that launch costs would also be higher. Is that likely to be offset by the energy savings from solar? It's unclear.
I think the costs of doing this are large and, at the moment, unknown. We need to collect data, we need to run experiments, we need to explore the design.
Let's be honest, the return on investment, probably not worth it. I mean, I'm gonna take a wild guess because technology goes so fast, it might become obsolete at one point, and now the tech is gonna. Now you have a bunch of flying junk that didn't fucking get the money back. You know what I mean? And then it's like, well, okay, well now we need new shit, and it's like you never really get there, do you?
Space and figure out what combination of technologies will allow us to get to orbital computing.
Chat, why don't they just build the data centers and they slam those motherfuckers under the ocean? You slam the whole server and you put a big ass plaque at the top. The slab is flat out in the ocean and it just cools by induction straight up. Bonk. What? Also, why not just build it in Antarctica? If you're gonna send some fucking thing into orbit, why not just fucking send it on an ice? If you build the server on ice, why would it get hot? It's on ice. Like, it literally can't. I mean, fucking checkmate. I mean, dude, what am I telling you? Checkmate.